We are beginning a unit on factoring. In this first video, we will learn how to factor the greatest common factor out of a polynomial. But first, here's an introduction to factoring. Factor as a verb means to write as a product. And product indicates multiplication. So for example, we could factor 15 into 5 times 3. We could factor this trinomial into x plus 3 times x minus 4. And the great thing about factoring is that you can always check it by multiplying. So if I wanted to check that I factored 15 correctly, then I would multiply 5 times 3 and make sure it equals 15. If I wanted to check my factoring on this polynomial, I would multiply, I'm going to use FOIL to do that, x plus 3 times x minus 4. So we do first x squared, outside negative 4x, inside positive 3x, and last negative 12. Combine like terms in the middle, which would be negative x or negative 1x, and that is equal to this polynomial that we started with. So then we know our factoring is correct. So it's a very good thing to do to always check after you've factored. And that, of course, is why it was so important that we learned how to multiply polynomials in Unit 1. Okay, greatest common factor, abbreviated GCF. To find the GCF, the first thing you do is find the largest number that divides all the coefficients. So you can remember, because it's greatest, that you're looking for the largest number that divides all the coefficients, the numbers that are in front of the variables. That's what the coefficients are. So like if I had 10x to the fourth, let's say we had 15x cubed, and we had 25x squared. And we wanted to find the GCF of those three terms. The coefficients are the 10, the 15, and the 25. The greatest number that will divide all three of those is 5. So that's what you start with. Then second, use the smallest exponent for any common variables or common expressions. They have to be in common. So if we look back to this example, all three of these terms have x. X is in common. That means we're going to put x in our GCF to the smallest exponent. So we've got 4, 3, and 2 as the exponents. We pick the smallest, which is 2. And then step 3 says form a product. So these are multiplied together. We don't have to write a multiplication symbol. It's just understood to be multiplied. And so the entire GCF for these three terms would be 5x squared. Now, when you do it for a polynomial that has addition and subtraction signs in it, you are going to find that GCF and you're going to write it down first. You'll write it in the front. So look at number 1. I start by thinking about 16 and 24. I want the biggest number that would divide both 16 and 24. We're going to put an equal sign here because we're saying that this polynomial is equal to, and of course that's 8. 8 is the biggest number that divides 16 and 24. Then I look for common variables. Well, the first term has an x, but the second does not. So x is not in common. Then it does not go in our GCF. It's just 8. Now, once you write down that GCF, you are going to open parentheses. Because remember, to factor means to write as a product, to write it as multiplication, and that's what we're doing with the parentheses. Now, to determine what goes inside the parentheses, you are dividing each term of that polynomial by that GCF. So I'm going to start with 16x divided by 8, which is 2x. And then I'm going to do negative 24 divided by 8, which is negative 3. And close. And that's it. This is our answer right here. Now, we're just dividing in our heads, but if you needed to, you could write out, okay, I'm doing 16x divided by 8. I'm doing negative 24 divided by 8. And so that's going to be a 2x minus 3 that goes in the parentheses. So if it helps you to write that out, you can. Now, here's another way that you might like to think about it. Maybe you want to think about it as whatever I write down here first has to multiply by 8 to be 16x. So 8 times what equals 16x? Well, 8 times 2x. And then 8 times what equals negative 24? Well, that would be negative 3. So just another way that you could think about it. And then to check it, you would actually multiply, and here that would just require distributing. So you do 8 times 2x equals 16x, and 8 times negative 3 is negative 24, which is what we started with. So now we know that we have factored correctly. To make sure you got the greatest common factor out and not just any common factor, then look at the numbers that are inside the parentheses. There's a 2 and a 3. And they don't have a common factor other than 1. So we know that 8 was the greatest. But let's just say we were working this problem and we didn't think about 8. We only thought about 4 as a common factor. And so we went back to our original and we said, okay, I'm going to pull out a 4. So if I divide each by 4, I'm going to get a 4x. And then negative 24 divided by 4 is negative 6. And if I check that by distributing, 4 times 4x is 16x, and 4 times negative 6 is negative 24. So it is a correct way of factoring. It multiplies back to equal your original problem. However, it is not factored completely, because if you look inside the parentheses, 4 and 6, they still have a GCF. They are both divisible by 2. So you could, at this point, keep your 4 and put it down in front, and then say, okay, now I'm going to pull the 2 out of those. So if I divide them by 2, I would get 2x minus 3. And now multiply the 4 and 2 out front, and I could eventually get to this same answer. It's always easier to get that greatest common factor out from the beginning instead of having to do several steps like this, but either way is acceptable. Just make sure that you always check inside your parentheses to see if it could factor further. We always want to factor completely. Okay, look at number 2. So we want to try to find the greatest, the biggest number that divides 24, 18, and 12. So maybe 2 is the first number that comes to mind because they're all even. But always think about, is there something bigger? Maybe 4? No, 4 won't go into 18. What about 6? Yes, 6 will divide all of those, and that is the largest number that would divide all 3. So you're going to put equals, and then you're going to write down your 6. And then you're going to look at your variables. Every term has an x, so x is in common, so x goes in the GCF to its smallest exponent, which is a 2. So that's the GCF, 6x squared. But we are factoring it from the polynomial, so once we write that down, we open parentheses. And then we divide each term by 6x squared. So we do 24 divided by 6 is 4. And when we divide the variables, remember that exponent rule. If you're dividing with the same base, you subtract the exponents. And so I'm going to do x to the 5th divided by x squared. is 5 minus 2 is going to make x cubed for that term. Then the second term, think about the sign. It's a negative divided by a positive, so you're going to write a minus. And then 18 divided by 6 is 3. And when we do the x's, we're doing 3 minus 2, which is just x to the first power. And last, they're both positive, so you put a plus sign. 12 divided by 6 is 2. And x squared divided by x squared is just 1. That multiplies by the 2, and it's still 2. So we don't need any x's there. Check to make sure that we've got the greatest common factor. 4, 3, and 2 do not have any common factors other than 1. So that means the 6 must be the greatest. So it can't go further. But it's probably a good idea to go ahead and check it. And sometimes you can just check in your head. But I'm going to go ahead and write it out here. We would check by distributing. So we would take 6x squared times 4x cubed, and that would be 24. When we multiply, we add the exponents. So x to the 5th. And then times the second term. 6 times negative 3, negative 18. X squared times x, x cubed. And then last, 6 times 2, positive 12, and you would still have your x squared on there, which is equal to your original problem. Therefore, your factoring is correct. Now, these two look a little different. They do have a GCF. It's the part that's in the parentheses. So, think of this as a term. X times x plus 3 is one term, and negative 4 times x plus 3 is your second term. Remember, when you're multiplying, it just makes one term. So what do these two terms have in common? Well, obviously, both of them have x plus 3. We're not really thinking about coefficients here when it's written in this form. We just look and say, okay, it's obvious that both of these terms have x plus 3 in it. So x plus 3 is the GCF. And so we write it down. Always write your GCF in the front. And because my GCF has two terms in it, I'm going to go ahead and put parentheses around it. Those are required here. We didn't need them on the problems over here. When I had 8, I don't have to put parentheses around the 8 because it's just a single term. You could, it wouldn't hurt anything, but don't have to. But that x plus 3 does require parentheses. And then we open. And we think about, well, if I have x times x plus 3, and I divide it by x plus 3, then that's going to leave me just x, and so x goes here. And now if I have negative 4 times x plus 3, and I divide it by x plus 3, that leaves me the minus 4. So basically, whatever's in front of the parentheses will go into this second set of parentheses. Every time it's going to work that way, as long as what is inside the parentheses is exactly the same. Now, multiplication is commutative. So if you wrote this as x minus 4 times x plus 3, that would still be correct. Just like 2 times 3 is the same answer as 3 times 2. It works that way for polynomials. So it doesn't matter really which order you have those factors in. However, I like to always just practice putting that GCF first, because when it is a problem like the ones on the previous slide again, that 8 really needs to sit in front of the parentheses. Okay, look at number 4. So here again, you just glance at the problem, and what should stand out to you is that both terms have 3b minus c. So that is the GCF. So we're going to write it down first. 3b minus c. And it does need parentheses around it. And then we open. And the shortcut is whatever's left in front after you take that 3b minus c out is going to go here. So that's the 2a and the plus 7b. So every time it's going to work that way. And it is the result of what you get when you divide each term by that 3b minus c. Now think about why those parentheses are important. If we wrote this and we didn't put that 3b minus c in parentheses, it would just look like only the c is multiplied to this polynomial here. And if you were going to check it, only the c would distribute, which would not equal your original. So it is important that you get the parentheses around that 3b minus c. And so we would just leave our answer right like that. Okay. So hopefully we're getting kind of the hang of factoring out the GCF, but one thing we need to note is that if the leading term, the first term, is negative, then we want to include that negative in the GCF. Even if there were nothing else in common, we would still pull the negative out. So look at number 5. And I see that my very first term is negative, so definitely I'm going to put equals, and then I'm going to pull that negative out. Then I'll check my coefficients. I've got 5 and 10, and their greatest common factor would be 5. 5 will divide both 5 and 10. And then I look at my variables. They both have y, so I need y in my GCF to its smallest power, which is 1. So my GCF is negative 5y. Then I open. And I divide by a negative, so be careful with your signs. So we're doing negative divided by negative is going to make this a positive. 5 divided by 5 is 1. Y cubed divided by y would be y squared. Now in the next term, it's positive divided by negative makes this negative. And 10y divided by 5y is just 2. And that would be our answer. Let's check it. If we distribute, negative 5y times y squared would be negative 5y cubed. And negative 5y times negative 2 would make a positive 10y, which is equal to our problem. Definitely a good idea to check there to make sure you have the signs correct. Let's go ahead and do one more. This one again has a negative on that first term. So we're going to pull that negative out, and then we're going to check the coefficients. 6, 12, 3. 3 would be the greatest number that divides all of those. You know what, I'm going to make that a little smaller to make sure I have room here. And then I'm going to look at my variables. They all have a. Smallest power on a is 1, so just 1a. They all have b, and the smallest power on b is 1. So that is my GCF. Negative 3ab, and then we open. It's just one term, so it does not have to have parentheses around it. Then we divide. Negative 6 divided by negative 3 is a positive 2. A to the 5th divided by a is a to the 4th. Remember, we're subtracting the exponents when we divide. So 4 minus 1 is going to make it b cubed. Okay, positive 12 divided by negative 3 is going to be a negative 4. And then for the a's, 4 minus 1, this will be a cubed. And b, 2 minus 1, so this is just b to the first. And last term, negative 3ab divided by negative 3ab, if they are exactly the same, it's equal to a positive 1. Think about it as a fraction. If I have negative 3ab and I divide by negative 3ab, top is exactly the same as the bottom. It always equals 1. Just like, 5 divided by 5 is 1. And if you're unsure about that, let's check it to make sure that really does work. So we're going to distribute. All right, so here's our check. Negative 3 times 2 is negative 6. A times a to the 4th would be a to the 5th. And b times b cubed is b to the 4th. So far so good. That's the same as the first term up here. Second, negative 3 times negative 4 is positive 12. A times a cubed, a to the 4th, b times b. And that term is the same. Now look at this last one. If I take a negative 3ab times a positive 1, it is negative 3ab, which is what my third term was. So that's good. It means this is correct. Now, a lot of times I'll see students leave this one off. They kind of think that if these two are the same, you don't need to write anything there, which is not true. It wouldn't check if I didn't have that 1. These have to multiply together to equal that term. You have to have the same number of terms in the parentheses as you did in your original polynomial. Now, if the one were multiplying by some variable, then that one would not have to be written. But because it is not multiplied by anything, the 1 does need to show. Okay, so I'm going to go ahead and stop here. If you want to go ahead and practice the GCF in the homework, you can do that. And then we will cover another type of factoring in the second video.